Hi, welcome to Sunil Maths tutorial. In this video, we learn about moments. Let us see the introduction of moments. The measure of central tendency means which represents the location. The measure of dispersion means which represents the variation of the data. Both are useful to describe a data set, but both of them fail to tell anything about the shape of the distribution. Remember that. The measure of central tendency, the measure of dispersion, both of them are failed to describe the shape of the distribution. So we need some another certain measure. We need some another measure, which are called moments, to identify the shape of the distribution. So the need of moments are to describe the shape of the distribution, to describe the shape of the distribution. Where the central tendency and measures of dispersion are failure, there we use moments to identify the shape of the distribution. Let us see the definition of moments. Moments are nothing but statistical averages. They are nothing but statistical averages. They are two types: non-central moments and central moments. Non-central moments are also known as raw moments. The central moments are known as moments about mean. Moments about mean. So remember that moments are nothing but statistical averages. They are basically two types: non-central moments and central moments. The non-central moments are also known as raw moments. Central moments are nothing but moments about mean. Let us see the definition of non-central moments. Moments about an arbitrary origin. The moments defined about an arbitrary origin, about any origin, are known as raw moments or non-central moments. The rth moment of a variable capital X about any point x is equals to a. The rth moment of any variable capital X about any point capital X is equals to a is denoted by the symbol mu r dash. Is denoted by the symbol mu r dash and defined as follows: mu r dash is equals to 1 by capital N into summation over I is equals to 1 to N Fi xi minus a whole power r, where capital N is nothing but sum of the frequencies. Summation over I is equals to 1 to N Fi. So the rth moment about any point x is equals to a is denoted by the symbol mu r dash and defined by mu r dash is equals to 1 by n into summation over I is equals to 1 to n Fi xi minus a whole power r. Let us substitute di is equals to xi minus a. Replace xi minus a by a variable di. Then we get mu r dash is equals to 1 by capital N into summation over I is equals to 1 to n Fi di power r. What happens if a is equals to 0? If a is equals to 0, automatically the di becomes xi. That's it. If a is equals to 0, then di becomes xi. In this case, mu r dash is equals to 1 by capital N summation over I is equals to 1 to n Fi xi power r. Whenever the arbitrary point is origin, a is equals to 0. In such a case, mu r dash is equals to 1 by capital N into summation over I is equals to 1 to n Fi xi power r. The moments given by equation 1 are called the moments about origin. The moments described in equation 1, these are known as the moments about origin. So the rth moment, one of the very important point to remember, the rth moment about origin 0 is mu r dash is equals to 1 by capital N summation over I is equals to 1 to n Fi xi power r. Now we substitute r is equals to 0, r is equals to 1 and up to r is equals to 4. If r is equals to 0, then what happens? Mu naught dash is equals to 1 by capital N into summation over I is equals to 1 to n Fi, because anything power 0 is equals to 1. Because anything power 0 is equals to 1. So you simply get 1 by n into summation Fi. This summation Fi is nothing but capital N. So N and get cancelled, you get 1. Mu naught dash is equals to 1. So mu naught dash is equals to 1. Put R is equals to 1. Put R is equals to 1. If you put R is equals to 1, then mu 1 dash is equals to 1 by capital N into summation over I is equals to 1 to N Fi xi, which is nothing but mean of the variable, which is nothing but mean x bar. So mu 1 dash is nothing but mean x bar. And similarly, if R is equals to 2, we get mu 2 dash like this, 1 by N summation over I is equals to 1 to N Fi xi square. If R is equals to 3, we get mu 3 dash. And similarly, if R is equals to 4, we get mu 4 dash. Observe that. So that's it. Let us go for the moments about mean. The moments about mean, which are also known as central moments. Which are also known as central moments. The moments about the mean, the moments about the arithmetic mean x bar, the moments about the arithmetic mean x bar are called central moments, which are also known as moments about mean. Moments about mean. The rth moment of a variable capital X about the mean x bar. Observe the symbol. The rth moment of the variable capital X about the mean x bar is denoted by the symbol mu r. Is denoted by the symbol mu r. So mu r represents central moments. Mu r represents central moments. Mu r dash represents non-central moments. Remember the symbols carefully. Remember the symbols carefully. Mu r central moments. Mu r dash non-central moments. So the rth moment of a variable capital X about the mean x bar is denoted by mu r and defined by the equation mu r is equals to 1 by capital N into summation over I is equals to 1 to small n Fi xi minus x bar whole power r, where n is equals to sum of the frequencies. Again, put zi is equals to xi minus x bar. Then we get mu r is equals to 1 by n into summation over I is equals to 1 to n Fi zi power r. In this formula, substitute r is equals to 0. In this formula, substitute r is equals to 0. We get mu naught is equals to 1 by n into summation over I is equals to 1 to n Fi. Again, which is nothing but 1 by n into n, you get 1. So mu naught is equals to 1. Already we proved that mu naught dash is also equivalent to 1. Mu naught dash is also equivalent to 1. Here mu naught is equals to 1. Now take r is equals to 1. If r is equals to 1, we get mu 1 is equals to 1 by n into summation over I is equals to 1 to n Fi zi. Fi zi. What is zi? Xi minus x bar. Split the summation. 1 by n summation I is equals to 1 to n Fi xi minus 1 by n summation I is equals to 1 to n Fi x bar. This x bar does not influenced by our summation. So write outside the summation, that x bar. So again this one, 1 by capital N into summation over I is equals to 1 to n Fi xi is nothing but mean x bar. Mean x bar. Minus 1 by n x bar into summation over I is equals to 1 to n Fi. Here you observe that this is n and this is also n. They get cancelled. You get x bar minus x bar, which is equals to 0. So mu 1 also equivalent. Mu 1 is equals to 0. Here you observe that. Mu 1 is equals to 0. Put r is equals to 2. Put r is equals to 2. We get mu 2 is equals to 1 by n into summation over I is equals to 1 to n Fi zi square. What is zi? Xi minus x bar whole square. Use a minus b whole square formula. Use a minus b whole square formula here. So you get 1 by n into summation over I is equals to 1 to n Fi xi square minus 2 xi x bar plus x bar square. Split the summation. Apply summation to every term. 1 by n summation over I is equals to 1 to n Fi xi square minus 1 by n 2 x bar summation over I is equals to 1 to n Fi xi plus x bar square by n summation I is equals to 1 to n Fi. So let us simplify here. This is nothing but summation over I is equals to 1 to n Fi xi divided by n is nothing but x bar. That is the nothing but formula for x bar. X bar is equals to 1 by capital N into summation over I is equals to 1 to n Fi xi. This is x bar. So we get 2 x bar into x bar. And here summation I is equals to 1 to n fi is nothing but n. So n get cancel, minus 2x bar square plus x bar square. Minus 2x bar square plus x bar square. That is nothing but 1 by n into summation over I is equals to 1 to n fi xi square minus x bar square, which is nothing but variance. Which is nothing but variance. Therefore, mu2 represents variance. Mu2 represents variance. 1 by n summation I is equals to 1 to n fi xi square minus x bar square is nothing but the variance of the distribution, variance of the random variable. Similarly, if we substitute r is equals to 3 and r is equals to 4, we get mu3 and mu4. Let us see one note point, which is important one, which establishes the relation between mean and the moment. Observe that. Take di is equals to xi minus a. Take di is equals to xi minus a. Multiply on both the sides with fi. Multiply on both the sides with fi. Fi di is equals to fi into xi minus a. Take summation I is equals to 1 to n on both sides. Take summation I is equals to 1 to n on both sides. And divide on both the sides with capital N, or multiply with 1 by capital N. Multiply with 1 by capital N. What is this? What is this? The left side is nothing but mu1 dash, non-central moment, mu1 dash. 1 by capital N summation over I is equals to 1 to n fi di is nothing but mu1 dash. In the right side, we have split that summation, split the summation. 1 by n summation I is equals to 1 to n fi xi minus a by n summation fi. This n and summation fi get cancelled because both represents capital N. So we get x bar minus a by n into n. Finally, we get x bar minus a. What it means? Mu1 dash is equals to x bar minus a. Mu1 dash is equals to x bar minus a. It means x bar is equals to mu1 dash plus a. The definition of moments and definition of non-central and central moments, both are very, very important for your end semester examination. Keep learning,